In this video we are going to see an example of inverse Laplace transform. Here we are going to do the inverse Laplace transform for this function. Here we have a function with s on the numerator, and we have in the denominator we have a quadratic formula. When we have quadratic formula we can factor that one out, but this is not factorable, right? You can see that s square plus 8s plus 19, this is not in pattern of a square plus 2ab plus b square, right? So to bring that pattern, what we can do is we can complete the square. To do that, what we do is we multiply this one by half times 8, then square this one. That's going to be the value we are going to add, and if you do that, this is going to be 4 square, that's going to give us 16. That's the value we are going to add. So we are going to have Laplace inverse, and here we are going to have s over s square plus 8s plus 16. But if we add 16, we have to subtract 16, right? So we subtract 16, we put plus 19 here, and then subtract 16, and if you do that, we are going to get this one. Okay, s over, we can factor this one out right now because this is 4 square, right? So s plus 4 whole square, s plus 4 whole square, and here we are going to have plus 3, and that's it for this one. Now let's compare this with the this is our reminder, like when we have this kind of pattern, it should be one of these, like cos bt or e power at sin bt, but this is almost matching with cos bt because we have s on the top, right? So we can compare this one, but we have to have the negative in the denominator. Here we have positive. To turn this one into negative, what we can do is we can write this one like Laplace and s over s minus minus 4, okay, minus minus 4, then whole square, plus here we have b square, right? But we don't have any square pattern. What we can do is we can make this one as square root of 3, then square that one. So this is going to be square root of 3 square. And also we had to have s minus a on top. In our case, s minus a is this value, right? If you look at this one, this is s minus a square. So this s minus minus 4 is the s, this value, right? So what we can do is we can write this one as it is, but when we do that, we have to subtract that one too, because when we write this one on top, we are adding 4. We are adding 4 to this one. When we add 4, we have to subtract 4, okay? Because this is not existing, we are adding to make this one, to bring in this pattern. And in the denominator, we are going to have s minus minus 4 square whole square, and then plus square root of 3 square, right? Now we have this pattern. We have brought to this pattern until this one, okay, until this one is this pattern. This negative 4 doesn't belong in this pattern because we had to have s minus a over s minus a square, and also we had to have plus b square. We have that pattern, but we have a negative 4, so we have to do something. What we can do is we can separate this one as a different one, like let's look at this here. Okay, here we are going to write, okay, s minus minus 4, and we are going to bring this negative 4 to this side, and we are going to bring the whole denominator here. This whole denominator is going to come here, so this is going to be negative 4 whole square plus square root of 3 square, and here also we are going to have the denominator. This is going to be s minus minus 4 square, and then plus this one is square, right? This one is square. So here we are going to have square root of 3 square. Now here we have this cos pattern, but let's look at this one. Here we have almost related to sine pattern, but in sine pattern we have to have this b value on top. So in our case, b value is root 3. We have to have that root 3 on top. So what we can do is we can get rid of this 4, like we can take this 4 outside. Okay, let's write this one here. We are going to have s minus minus 4 over s minus minus 4 whole square plus square root of 3 square, right? And we are going to bring the negative 4 to the front because it doesn't matter, but we are going to put root 3 by root 3, right? This is like 1. So in that way we can bring this pattern, we'll bring this e power 80 sine bt pattern, but we have to have this top root 3 here, but we don't have to have this negative, I mean the bottom denominator root 3. We have to get rid of that one. So what we can do is we can bring that root to the front. So this is going to be 4 over root 3, 4 over root 3, and here we are going to have root 3 over s minus minus 4 whole square plus square root of 3 square. Okay, now we can go ahead and write in this pattern. That's going to be our Laplace transform. So when we do that, this one is going to become, let's write our AB values. Okay, for the first one, A value is whatever the value we are subtracting. Here we have negative 4, that's our A value, and B value is this one, root 3. Okay, B is root 3. Now let's look at this one here. Here we have B value is root 3 and A value is negative 4. So it's the same thing. A is negative 4, B values root 3. So we can go ahead and write this one. Now this one is going to be directly like this. So we are going to have e power a t. So a is negative 4 and t. Then we are going to have cos bt, cos root 3t. Okay. And after that we are going to write this one. Here we are going to have negative 4 over root 3 first. And after that we are going to convert this part into sine function like this. So this is going to be e power a is negative 4t, and then b is going to be root 3, so this is going to be sine root 3t, and that's going to be our final answer. That's going to be the inverse Laplace transform for this given function, and that's how we do this kind of problems. I hope this helps. Thanks for watching.